think I should get rid of this green. It's not working anymore. I'll take it. Recycle. Okay. So here's 15. In 15 we have log of x to 15th, y to 13th over z to 19th. We're asked to expand. Let me go back one page back. Here we're given 1, 2, 3 logs, and we condense the whole thing into one log. Here we are given one log, and they want us to expand into simple logs, applying 3 properties that we have. We may apply all of them, or we may not apply all of them, but that's all we have available. We have to start in this situation, we have to start with log applied to a ratio. That's the starting point. So log applied to a ratio equals log of the top minus log of the denominator. The ratio, the quotient rule is gone. Now we have a product. We will apply log applied to a product, which means log of x to the 15th plus log of y to the 13th minus log z to the 19th. We still have one more property to apply. Now, I just would like to caution you on something. If you're given this and asked to condense, how many quantities are coming from the denominator? Just the one with minus in front. Just one. How many come from the numerator? 2. The ones with the plus in front. So keep that in mind, because this is a shortcut and it's important. So finally, I apply the last property, in which I'm allowed to bring the power in front as a factor. And this is it. We expanded this log into simple logs. We can't go any further. We also wanted to look at number 19. Any questions about this one? Yes, please.
Can you have negative coefficient with x on top?
This one is the only negative because it's coming from the denominator.
No, let's say in the question if we had negative coefficient.
Say it again. If the question will have
Negative coefficient.
no, because you can consider a negative if you want, but if you put negative as z to the negative 19th, it will still end up in the denominator as 1 over z to the 19th. I see your question. Is that your question? That the power of z could be negative 19?
Yeah. So in the numerator,
Yes, but it's the same thing, because z to negative 19 will still be 1 over z to the 19th.
no, if we had negative on the upper side, in the numerator with x,
You mean here, power?
no, with x,
Where the x is?
yeah,
If this is negative,
negative x raised to power 15 if we had that situation.
you mean if there is a negative here,
No, in the base.
inside?
Yes.
You can, but then the domain has to be adjusted. But you can have negative x. That's fine, yes. You can have negative x, assuming that x is positive. Was that the question?
Yeah, I was confused with numerator and denominator.
So when we apply the quotient rule, the quotient rule says log of x over y means log of x minus log of y. So we have to start with that. Log of the numerator minus log of the denominator. Then we have a product. So this is log of x to the 15th plus log of y to the 13th. And then I copy this. And then the powers go in front.
Okay.
Maybe I didn't answer your question.
Okay, at the end of the class, I will discuss.
Okay, yes. So you're saying if there is a minus in here,
Yeah. That's,
it doesn't matter. It's a product. This is your product. Even if you put a minus in here, it's still a product.
so, but in the end, like if we go back, then that thing will come in the denominator again, right?
The power. So if it's in the if you have a negative here, that's not going to change the position because it's log applied to this quantity. What is in the denominator will have a negative in front. Only the quantity that is in the denominator. But if you have a negative power, then you will bring it down from the very beginning. But if you have negative, then it will stay negative. You don't have anything else. The negative in front will not affect the power. It will not affect the position of the quantity. So I see now. So if I have -2 in the numerator, I'm not going to say, oh, I want to move it to the denominator. I can't. Unless it has a negative power, not negative in front.
Okay.
Is that better?
Yeah.
Perfect. Yes. Son?
Won't there be a negative sign with the y too? If we're putting the negative sign with x?
Yeah, but I don't want to change everything. I don't want to change the problem.
Because you put it before x, so wouldn't there be a negative sign before y?
Right here. No. So if there is a minus in front of a fraction, and you have two factors at the top, you're not distributing. This is not a distributive law. Okay, hold on. So if I have -2x, it doesn't mean that it's -2 and it's -x. It's like this, which is a distributive law, but this is not a distributive law. This is just -2x. So if I have -x to the 15th, y to the 13th, it doesn't mean that -x and -y. Because then it's going to be positive. But if you distribute -1, it's a different story. Then you get -2 and -x. But if it's a product, you're multiplying. And you are not distributing. So it's just simply -2 times x. It's not -2 times -x times -y times, no. It's just one number, -2 multiplied by x. Is that okay now? Perfect. So please don't change anything here. This was just an explanation. So there is no minus here. And the negative or the positive do not affect the position. Only if the negative, the exponent is negative. Then what is in the denominator has negative in front. Okay, we're looking at 19 now. 19 is log of x squared y cubed and the cube root of x squared y to the 5th. I think this is a not very friendly situation, but I will simplify because I see 5 and 3. So I will change the inside into, I will keep the cube root of x squared because there is nothing I can do to that. But then I will take the integers out from here. So I will have y and the cube root of y squared. There is no point in having a y and another y underneath, right? Because there is y and I will multiply y by y cubed. So I'll simplify the expression inside a little bit, if possible. And it's possible this time. So log x squared y to the 4th, the cube root of x squared, and the cube root of y squared. And now I will proceed.
Is it y squared or y to the 5th? On the top, is that?
I think it's y to the 5th. Let me check because sometimes I see y to the 5th. Yes. So since it's y to the 5th, it's y cubed times y squared, and I took the cube root of out. So
Would you not just combine all terms there? So you only have.
there are factors. Careful, there are factors. So I'm multiplying y cubed by y, and I get y to the 4th. Oh no, I'm not going to combine these two.
You
Only
would want to.
I can, but I'm going to have log of this plus log of this plus log of this plus log of this. So if I combine them, I still have to separate them in a minute. So this is log x squared plus log y to the 4th plus log of the cube root of x squared plus log of the cube root of y squared. Yes, I'm going to put the power in front right now. Yes, of course, right this moment. So the power rule will bring 2 in front. So 2 log x plus 4 log y plus bless you, 2/3 log x and plus 2/3 log y. Now, since we have log x and log y, we can combine like terms and find the least common denominators, etc., 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 and I will. So 2 plus 2/3. We multiply the top by 3. 6 plus 2 is 8, so 8/3 log y, and plus 14/3 log x. Oh, sorry. So that's 8, yes, that's correct. It's x, I'm going to erase that, and 14 log y. So it's x, the first one is x.
So if you have the same base and everything, you could just add them together like that.
Say it again.
Combine all these terms because they have the same
These
log
two?
base.
I can't.
Well, not the x's to the
one
y,
above,
the
the
x's
one
plus the x's.
In the other. Oh yeah, only because I have 2 log x plus 2/3 log x. Yes, only because they have the same base and they have the same x. I could have not, if I had log x, log y, z, and t, I would have not. I would have just left it alone. Any questions? Any questions? Yes, please, go ahead.
So we'll like back to the original, just
Yes.
cube root x squared y to the fifth.
Mhm.
And then I can see how it goes cube root x squared.
Right?
But I don't understand how you go from y to the fifth to y to the second.
Very good. Let's take a look at that. So when we take the cube root of y to the fifth, because the power is bigger than the index, we will separate it into y to the third and y squared. And this becomes the cube root of y cubed times the cube root of y squared, and this becomes y, the cube root of y squared. Is that what you're asking? Is that clear now? And this is only because the exponent is bigger than the index. Otherwise, I would have not been able to do anything. So on the previous one, we had the cube root of x squared. It's carved in stone. I can't do anything to it. Because the index is bigger than the power. Or if you want, the power is smaller than the index. Yes, Arthur, you wanted to say something? Anyone else? Okay. Finally, we're doing all this in order to be able to solve equations. That's the purpose of all this. Exponential equations. I'm going to make up a few equations because I want to build the level of difficulty, and then we can choose anything you want from problems we have available. Okay, so here's the first equation. 2 to the x equals 2 to the third. Yes, of course, I'm going to ask myself what type of equation is it, and obviously since the variable is the exponent, it must be an exponential equation. It cannot be square root or rational or anything else. So, no, we do not cross out the bases. So here's how we think. Two numbers are equal, and they have the same base. What has to happen to their exponents? They must be the same. This is not that function that has that property. So then from here, x must equal 3. That's the simplest possible exponential equation that I can think of. Okay, the next level. 1/8 x raised to 2x plus 3 equals 32 to negative x plus 2. Okay, this is not the simplest possible exponential equation. It's obviously an exponential equation. And my next thought is, can I make this number and this number with the same base? Not true. Can be 3 or 5 or 10, it doesn't matter. But can I present them with the same base? And the answer is yes. Because 1 over 8 is 2 to negative 3. And 32 is 2 to the 5th. So this is still not a very difficult situation. Because both sides could be presented with the same base. As long as I notice that 1/8 is 2 to negative 3, and 32 is 2 to the 5th, and I copy the base. And now can anyone tell us what happens to these exponents?
They're added to each other.
Yeah, I copied the base, but look what I copied. So 2 raised to, what do we do with them again? I'm sorry. Yes, perfect, we multiply. So we copy the base, we multiply the exponents, and we get negative 6x minus 9 equals 2 to negative 5x plus 10. Now, with a little bit of effort, I have to agree, we got back to the simplest possible exponential equation, in which we do not cross out the bases. We think two numbers are equal and they have the same base. If they don't have the same base, what I'm showing you right now fails. But if two numbers are equal and they have the same base, what must happen? Right, negative 6x minus 9 must equal this, indeed. And this is a linear equation. I move 5x, I get negative x. I move 9, I get 19, so x equals negative 19. Okay, here's the next level of difficulty. You can say, what's this? Well, it's still an exponential equation. The variable is at the exponent level. But this time, I have two options. I will say, let t be e to the x, and then change the equation. How? T squared minus t minus 2 equals 0, which I have no difficulty solving in terms of t. Flynn will correct me and say, I don't want to do that. Or Mike, last time, he said, oh, I don't want to do that. I don't want to use a substitution, which I completely agree. You can immediately say from here, e to the x minus 2 and e to the x plus 1, if you're comfortable with that. It's either one, it doesn't matter. So we have t equals 2 and t equals negative 1. I'm going along with my first option. So then this is a new equation, e to the x equals 2, and this is e to the x equals negative 1. And now, there is no way, absolutely no way, I can present e and 2 with the same base. At this point, I have to do something else. What we did, for example, similar to what we did when we solved this equation. What did we do here? Yes. Why? We applied the inverse function. The square root and squared. We apply natural log to both sides. We bring x in front. How much is natural log e?
1.
Very good. So then the first answer is natural log 2. Now we're going to discuss the second option. And before we discuss the second option, I would like to graph the second option. I would like to graph e to the x. Is it an exponential function with a base greater than 1 or smaller than 1? Excellent. Very good. It's e to the x. So I graph this piece. And now I want to graph the other side. And I'm going to ask you what happens here. What is the range of e to the x? One more time. What is the range of e to the x? 0 to infinity. And I'm asking you to find a point where e to the x with a range 0 to infinity crosses y equals -1.
No one.
Nowhere. Excellent. So e to the x will never be -1. So I'll say no solutions here. But the only solution of the equation is this. So
So that would just be considered extraneous.
that's the only solution, natural log 2. That's not possible. So this equation has the only solution x equals natural log 2. And we were not able to present both sides with the same base. It's not possible. Here's another example. Let's say 2 to x plus 1 equals 3. There's no way I can present 2 and 3 with the same base. Doesn't exist. And there is a way. And the way is the inverse function. But I don't want to apply log base 2 because I don't have it. I may not have it in the graphing calculator. I will apply what I have to both sides. It doesn't matter which one you apply, but it has to be the same. If you decide natural log, it has to be natural log on both sides. So you can bring x plus 1 in front. If you want log, we apply log. It doesn't matter which one, but the same to both sides. So then x plus 1, if you omit to put x plus 1 in parentheses, you are changing everything and you're not going to get the correct solution. So the power, whatever it is, becomes a factor in front. A factor means it's multiplied by log 2. So in order to solve for x, what would be the next step?
Divide log.
Exactly. So do not get scared about these. They're just simple numbers. They look super sophisticated. They're not. They're just numbers. And we subtract 1. Any questions?
Would you want to solve that further? Just find the exact number?
We cannot find the exact number. It's going to be an approximation. Very good question. But if I don't approximate it, I will not be able to see whether my solution is correct. So let's do just that. Baby, don't forget what you want to ask. 1 second. Just give me 1 second to do that.
So we leave the answer like you just left it.
Say it again.
So we just leave the answer like you just left
It depends. If it's a war problem, I will not tell you that I have in my pocket -$1 plus log base common log of 3 over common log of 2. I'll give you an approximation. So it depends. It depends. So this was -1 plus log 3 divided by log 2. And I get a number, whatever that is. So I raise 2 to power, in parentheses, the previous answer plus 1, close the parenthesis. When I hit enter, if I don't get
Three.
if I don't get 3, then the answer is wrong. Very good. Okay. I know I have 5 minutes left. I'm not going to continue with log equations, but I would like you to choose another exponential equation of your liking. So the log equations start here. We're going to do that on Tuesday. Please be prepared for a quiz, open notes, open book. So please choose another exponential equation, anything you like. The exponential equations are between 11 and 28. Nice try.
21.
We want to do 21. We just did one that is similar to 21.
28.
28. Yeah, that's fine. 28 is fine. I just didn't want to repeat it. I just want to show you another type. Ready? Please take the time this weekend for me, And if you'd like to shoot me an email and I say bravo and I have you and I love you, please redo this weekend both tests. Now, if you have 110, you probably don't need to do it every weekend. But if you did not get 110 or close to on both tests, please take the time for me and redo all tests, all versions, several times if you need to. I talk too much. I know you chose 28. Okay, so 3e to 3 minus 3x plus 6 equals negative 31. Was it 32 you said? So we said 28?
Yes.
Did we say 28?
Yes.
Okay, so 3e to 3 minus 3x plus 6 equals negative 31. Perfect. First step, please. Oops, no one can see. First step. Of course, it's not cleaned up. Very good. So 3e to 3 minus 3x equals negative 37. Yes, of course. E to 3 minus 3x equals negative 37 divided by 3. And now,
Natural log.
okay. Oops. What's the oops all about? Exactly. What's the problem?
Of course.
Why? Because e to any power cannot be a negative number. Say it again. Yes.
Alright, I'll do this.
Which one? 24. Let's start it. If we finish it, we finish it. If not, I will not hold you over. 4e to 3x plus 3 minus 7 equals 53.
Add 7 divided.
Yes? So 4e to 3x plus 3 equals 60. And then e to 3x plus 3 equals 15. And yes, 3x plus 3 on the left equals natural log 15 on the right. And 3x equals negative 3 plus natural log 15 and divide by 3.